So today we are to look at the operating system components. You remember in our last class, we did an introduction to the operating systems. We emphasized on the importance of the operating system in the computer system, and we also saw the position of the operating system with respect to the computer hardware and other software. And we saw that the operating system is actually that program that is responsible for managing the hardware. The direct connection with the hardware is the operating system. Other user programs are above the operating system, or they need the services of the operating system in order to access the physical computer resources. So we saw it very clearly that the operating system is an important component and a critical component in the computer system. Okay, we also saw some generations of operating systems. We saw the evolution of operating systems, how early computers did not even have operating systems, and then how operating systems have evolved to what we have today. Okay, so today we are now to look at some major components of the operating system. The major components of the operating system. Okay, and like we said last time, operating system is more of a resource manager. It's more of a resource manager. Means the operating system is responsible for managing the resources that you have in the computer system. And when we talk of resources, we are talking principally of the CPU. We are talking about the memory. We are talking about the file. We are talking about input, output. So those are some of the major resources that you have in a computer system that the operating system manages. Okay.
Yes, sir.
All right. All right. Now, the first component that we will look at is the process management. The process management. That is a component of the operating system. Process management. So before we look at process management, you need to understand what the process is. Okay. What a process is all about. And we know that a process is simply a program that is in execution. A process is a program that is currently being executed by the CPU. So it means when you start your computer and you launch a program, for example, you launch, like I have launched this program that I'm using to present this, or I have launched my Zoom. What happens is that there must be a process that is being executed for that Zoom. It might be one process, it might be several processes, okay? So it means that there should be an instance of that program that is currently being executed by the CPU, and that is a process. There are other programs in your computer that are not running at the moment. Maybe you are running just the Zoom application. At that moment, you will have the Zoom process. Maybe your operating system also has some system processes that are running at the background. They are always there. Okay, so a process is simply a program in execution. And once you have a program that is in execution, that program needs what? It needs resources. It needs, for example, it needs the processor time. It needs the processor to be able to execute some of its tasks, whether it is arithmetic or logic operations. It needs the processor or the CPU. And then it needs the memory, because the process will have some storage, some variables that it is manipulating. It needs to store those variables somewhere. So it needs memory in order to run. It also needs file. Maybe it needs to write on some files, or it needs to read on some files. A process will also need files, and it also needs input and output devices. Okay, it needs input and output devices in order to accomplish its task. Okay, so it's important for you to know exactly what the process is, to know that for any program that is currently being executed, there is a process. There could be one or several processes for one program, depending on the depending on the size of your program. A program can have 1,000 processes, 2 processes, 10 processes, depending on the size of the program. And you should know that each process or the process will need what? Will need some resources in order to execute. And the first resource that it will need, or some of the resources that it will need, will be the CPU time. It will need some memory, the RAM, it will need some files. It will need some input-output devices in order for it to be able to accomplish its task. Okay.
Yes, sir.
All right. Then you will see that in the operating system, in many operating systems, we have what we call the process table. We have the process table that holds this information about processes. The process table is like a table that holds this information for a running process. That is the CPU time and all of this. It is held in the process table. So it means every process will have what is called a process table. And a process table is nothing more than a data structure, which could be an array or maybe a linked list that enables it to hold the status of that process, to hold and contain the state of that process. For example, for each process should be able to say that, okay, this is my time that I need to execute to run on the CPU. This is my memory space that I'm using. These are the files that I'm manipulating. These are the input devices that I am using. Okay, so each process must have its process table where it contains the list of all its resources that it is going to need in order to accomplish the task. Okay, now you will see that like I said earlier on, in order to execute a single job, you can have 2 or more processes that are working. You can have 1, 2, or 1,000 processes that are working in order to accomplish a given task. For example, you can write a program that the kind of multi-threading is also a concept that we will see in Java. I believe we have the time to see it. You can write a program that is going to need several processes. And when you apply this concept of multi-threading, you also ensure that your program is or your algorithm is executed in parallel. It's being executed in parallel. Okay. So when you do that, it means that you can have, for a single program that is being executed, you can have several processes that are involved. Okay. And as such, these processes will need to do what? They will need to be synchronized in a way. They will need to synchronize their activity. If there's a process that is responsible for maybe there's a first process that needs to produce some output for the second process to use the output from the first process. Maybe you have, let's take a typical example. You are calculating maybe, let's just say you are calculating the GPA, for example, the GPA. You have that program to calculate the GPA. And in the GPA, you have a function that is responsible for calculating, calculating the coefficients. You have the function that is responsible for calculating the coefficients. You have another function that is responsible for calculating maybe the averages. Okay, let me just take a simple example. Let's say you want to calculate the GPA. Okay, and then you have process 1 that is taking care of what? That is taking care of the coefficients. Then you have process 2 that is taking care of maybe the averages. You have process 3 that is taking care of maybe what again after the average. Maybe you are calculating now, computing the GPA. Okay. Maybe in your program to calculate the GPA, you have these 3 processes that are running. Process 1 will have its own process table. Process 2 will have its own process table. Process 3 will have its own process table. Okay, and for each of the process 1 will, in its process table, will indicate which time it is going to go into the processor, which memory space it is occupying, what are the files that it is manipulating, what are the input devices, and that will be the case for all the processes. So you see that all these processes are intended to accomplish a given job, which is to calculate the GPA. But now they are separated. Process one has its own objective, which is to come out with the coefficients. Process two has its own objective, which is to come out with the averages. Process three has its own objective, which is to come out with the GPA at the end of it. Maybe process two needs input or the output from process one. Maybe the output from process one will serve as input to process two, and the output from process two will serve as input into process three. Okay, so you see that there is need for these processes to be synchronized. There is need for their activities to be synchronized, because if you start calling process three when process two has not computed the averages, process three will not be able to do any calculation. And if you want to call process two to calculate the averages when the coefficients have not been calculated, you see that it will not be possible. So you see there is need for this inter-process synchronization when you have several processes that are working for a particular task. Okay, and in that way you have what we call inter-process communication. It means that these processes must have a way of communicating. They must have a way of communicating. And just like we saw, I don't know if we saw that in our Java class, we saw the concept of message passing. Okay, the concept of message passing, communication between two objects, for example. Okay, and we said in I think I made mention of the fact that we will see most of that in operating system. When you have processes communicating with each other, you have message passing, or you could have all the processes having a shared memory, such that process one will just write its output in some memory space. Maybe it will write it in memory space, maybe memory space M1. And then what we'll do is that process two will go and maybe read from that memory space. Okay, process one could just, after having the results, store it in some memory space M1, which is a shared memory space between all these processes. And process two will come and read from this memory space. Once he finished reading, it will do what? It will compute, and then it will store the result again in the same shared memory, and process three will come and read from that shared memory. Okay, so you see that in this case, there is always need for that synchronization. And all these things, all this control and synchronization is being handled by the operating system, by this component that we call process management. It is taking care. Imagine that at one point, process two is trying to read when process one had not written in that memory space. What will happen? It will read, and then it will read an empty space. And what if process two, at the time another process wants to write something? Maybe there's a process for a different program, maybe process 5 for another program running. And this process suddenly wants to write something in this memory space. If it writes content in this memory space and process two comes and reads, thinking that it is from process one, you see the kind of results that you will have. So the operating system is able to control this, ensure that inter-process communication flows well, okay, and also the synchronization of the activities of the processes, okay. So now we'll look at the major activities of the operating system in relation to process management. It's simply responsible for the creation and deletion of processes, okay. If there is need for a new process, if the application that you are executing requires that a new process be created, the operating system will be the one responsible for creating that process. And maybe if after execution there is need to delete a process, the operating system will still be the one responsible for deleting that process, okay? And then we have also suspension and resumption of processes, okay? This happens in a situation where maybe, for example, the process is executing and maybe it runs short of resources, okay? Maybe process one is running and maybe it needed maybe some input output device, and that input output device is not available. What happens is that the operating system can decide and suspend this process. They call it a process is blocked or is in waiting, okay? You have a process that is executing and after some time it is in waiting. For example, if this process 2 is dependent on process 1 for the output of process 1, it means that at some point the activity of this process 2 must be suspended while waiting for process 1 to terminate, okay? It is the operating system that is responsible for suspending processes like that and even resuming. So the operating system will be able to suspend process 2 until the output is available and then resume process 2, okay? So the suspension and resumption of processes is also managed by the operating system. Inter-process synchronization is also taken care of by the operating system. And I believe we have explained already the need for inter-process synchronization. When you have processes that are two or several processes that are intended to accomplish a given task, they must be synchronized, their activities must be synchronized. And then we have inter-process communication. It's also handled by the operating system. Is it going to use message sharing, message passing, or is it going to use shared memory? And also there is also another important part that we will still look at, deadlock handling. The operating system also provides mechanisms for handling deadlocks. So a deadlock is simply a situation in a computer system where you have two processes that are blocked. For example, process 1 is waiting for some output from process 2, and process 2 is waiting for some output. Or process 1 needs a resource that process 2 is using. And at the same time, process 2 needs a resource that process 1 is using. And none of the processes is willing to release their resource, okay? Maybe process 1, maybe we want to write something. We need a book and a paper, a pen and a paper to write. And then Clinton has, we say go. Maybe we have like Clinton and Evany, for example. There is a pen and a paper lying down. Clinton is process 1. Evany, for example, is process 2. Okay, and they say Clinton needs to take the pen and the paper and write something. Evany needs to take pen and paper and write something. Okay, maybe when the bear will go back for them to start writing, what happens? Clinton picks the paper, Evany picks the pen. Okay, now Clinton has the paper, Evany has the pen. None of them can do anything. They cannot execute the task because for you to execute the task, you must have the two resources. You must have the pen and you must have the paper. Okay. Now, what will happen is that Clinton will be waiting on Evany to give him the pen so he can write. And at the same time, Evany will be waiting on Clinton to give the paper so she can write something down to accomplish the task. Okay. So what you will see is that both of them are waiting on each other on a resource. You have a resource that I need, I have a resource that you need, and none of us is is ready to release their resource. So this is a deadlock situation. So you will find yourself in a deadlock situation because you cannot move forward. Nobody can execute the task, and nobody is willing to release the resource for the other person. Okay, so this type of situations also happen in operating systems. or in computer systems. But now the operating system needs to be able to handle these situations. And there are techniques that the operating system applies in handling deadlock situations. Okay, we are going to see some of those techniques in our subsequent lectures. They can avoid the deadlocks. There are many techniques that they can use to handle these deadlocks. Okay, so that is basically or globally what the operating system does in terms of process management. So the component of the operating system that we call the process management is responsible for handling all these activities that we have seen. Okay, taking care of the process table, taking care of the resources that are allocated to the process, making sure that processes are created and deleted accordingly, making sure that processes are suspended and resumed when there is need. Okay, if there is need to suspend the process, it is suspended. If there is need to resume activity, it is resumed. Ensuring that processes, that there is inter-process synchronization for processes that are in achieving a common task or a common job, and then ensure that inter-process communication is also fluent. Okay, it's also efficient, and also handling deadlocks. Okay, is there any worry as concerns this now? I hope it doesn't look very strange to us, huh? What we are discussing is obvious, right?
Yes, sir.
Okay, all right. Okay, so that is it. Globally, we are going to go digitally to look at some of the algorithms that the operating system uses in order to manage the processor, okay, or in order to manage processes. Because the operating system needs to decide which process needs to be executed at this time, which process should be waiting, which process should be blocked, which process should be resumed. Okay, the operating system is able to determine that, and there are some algorithms that the operating system applies in order to do to accomplish these tasks of process management. Okay, we will see some of those algorithms. Now let's go to the second component, which is the memory management. Okay, the memory management is also another important component of the operating system. And we say that what? We say that the main memory is like a large array of words or bytes, and each word has its own address. Okay, so this is how the memory looks like. The memory is simply large array of it's more of a table. Okay, you have maybe you have address 1. Let me say address 1 is 0x0. You have address 2 0x1, for example, and you continue like this. And then you have address maybe xxx, for example. Let me just put it like this. Okay, or address n. Normally, memory addresses are presented in the hexadecimal number system. That's why I'm writing this. Okay, you have address n. So it is just like an array. In this address, you will have what? You have the content. In each of these addresses, you have the content. Right to here, you have the content. And it will now be an array, okay? Here, what is going into this content? What is going here? What is here? So that if you want to access content that is on this first table, on this first entrance, this is not actually a proper, it's more of a table, right? It is more of a table, like an array, right? It's more of a table like an array. But not that when we say a memory is a large array of words, each content having its address. This is how it is. It means that if you want to access what is here on this first line, maybe what is here is this. If you want to access this content, you will reference it from its address. If you want to access this other content, you will reference from its address, which is here. And this other content, you also reference from its address. Maybe the content is like this, okay? And then this one. So that is how the memory is organized, okay? If you know you need the content that is found at the address 0x1, you just come to address point address 0x1 and you pull what is inside, okay? So that's how the memory looks like. Now, generally, in very old or in very classic operating systems, only one program at a time is on the memory, okay? Only one program is loaded into memory at a given time. That is the classical functioning of the operating system. Only one program is available in the memory at a given time. But look at what we have today. At times you want to have your computer, put on your computer and you run like 5 programs at the same time. When you run 5 programs at the same time, it means the operating system should be able to make sure that all these programs can be contained in the memory. Okay, all these programs can be contained in the memory at that same time. Okay, but the traditional way is that you have one program at the same time in memory. But now we need to have sophisticated operating system because our needs are changing. And this sophisticated operating system should be able to allow multiple programs to be in the memory at the same time. Okay, now you need to understand from here, you need to start looking at what the operating system needs to do to ensure that several programs can be in memory at the same time and they are not conflicting, like they are still working efficiently. Okay, now we have the major activities of the operating system in regards to memory management. We have, it keeps track of which part of the memory is being used and by whom. Okay, it is very critical. The operating system needs to know which part of the memory is currently being used and by which process. Okay, so it means on the process in the memory, the operating system needs to know that, okay, in the memory space 1, process 2 is there. In memory space 3, it is process 1. In memory process space 5, it is process 2, for example. So it needs to keep track of which part of the memory is being used and by which process. Okay, and the operating system needs to also have a kind of visibility on which memory spaces are free and which memory spaces are used. Okay, so it is the operating system that takes care of that. If you launch your Chrome or your VLC to play your songs or watch your movies, the operating system needs to know that, okay, this program, VLC, is loaded in this part of the memory. Okay, and that if there is a second program that is coming up, the operating system needs to direct that program into a different space because that space has been, some other space has been occupied by VLC. Okay, if the operating system was not there to control this, it means that you will just launch a program and it takes any space in the memory, and when you launch the second program, that program might just override what the space that the other program was occupying. The program will simply crash. Not so, but the operating system should be there to manage this security, control this access, that when the memory space is allocated for John, Mary should not come and want to use that same memory space again. Okay, so it also keeps track of unused or free memory. If you should just knock at the door of the operating system at any time, the operating system will tell you which space in the memory is free, that is ready to be allocated. It also protects the memory space, like we have seen. It needs to protect if it has allocated memory, memory address, maybe address 1 to process P1. It needs to protect that speed so that no other process will come and use this space. And it decides on which process should be loaded into memory when the memory becomes available. That is the decision of the operating system. Okay, it allocates and deallocates memory space as needed. It is also taken care of by the operating system. Okay, so you will see that the operating system needs some algorithms or some tools in order to handle all these tasks. It needs some algorithms in order to ensure that, okay, which process should run into memory now? It should be loaded into memory. Which process will be loaded next? Is it by first come, first serve? Or is it by last come, first, last come? I don't know. There should be something.
First in, first out.
Voila. First in, last out, or first in, first out kind of thing. Round robin, we have techniques like that. So we are going to see some of the techniques that the operating system is using to determine which program should be in memory. Is it taking the shortest program first? Maybe the operating system might decide that, okay, if you have 3 processes, process 2 needs just one byte of memory, and process 1 needs 1 byte, and process 2 needs 3 bytes. Okay, I want to load the process with a small size first, for example. And what are the advantages? What are the inconveniences? Okay, so that's why you will see that for every algorithm that the operating system is applying, either for the management of the memory or for the management of the processes, there is always something to lose or something to gain. Okay, there's always something to lose. You must sacrifice something, and there are always like advantages and inconveniences of each algorithm. Okay, so when we talk about memory management for the operating system, you should know the major activities that the operating system is doing. It is keeping track of which memory space is currently being used. It is keeping track of free memory space. It is protecting the memory spaces. It is deciding which process should be loaded into memory. And it is also deallocates and allocates memory spaces when needed. If the operating system discovers that one process has hogged the memory, has been in memory for too long, what will it do? It can decide and to deallocate that memory from that process and give it to another process. Okay, so the operating system is responsible for all this. All right. Then anything you want to add? I hope I'm not speaking too low or too fast or too quick.
It's normal, sir.
It's okay, sir.
It's fine. Dayem, is the rhythm good? Dayem is in mode mute. Okay. So why have other people not been, why have they not been attending delegate?
So I can't tell.
Are they on strike?
I don't know, sir.
Or maybe they know what they count on. They have other things on which they count.
Maybe they are sleeping already, sir.
It's still bad. But you know that we cannot hold this class during the day, right? Because during the day, there's a lot of distraction. During the day, if we can only have a class on campus, okay? Because if we organize an online session during the day, I know that some people will be in the market, some will be at funny places, some will be walking under the sun and trying to follow the class. But I believe that by this time, everybody is settled. At least the responsible people should be settled home. I know that some are up and down drinking wine. Huh? Yeah, but now everybody is supposed to be settled. So when we come back, we'll continue with the other components. I think that will be the last slot. Let's just come back and see. We have 1 minute to